All right, so continuation of 9.3 in the textbook. I want to talk to you about horizontal asymptotes today. This is sort of the outline of what we're going to do. Degree of the numerator and denominator. Okay, we're going to talk about how we know what horizontal asymptote we have by looking at the degrees of the numerator and the denominator. Okay, this really represents sort of a shortcut for you. Okay, so if you remember these few rules, horizontal asymptotes won't be a problem. I'm also going to show you how to determine a horizontal asymptote from a graph, and specifically, well, two ways, I guess, from a graph that you might see on your test or in your textbook, and also from a graph that you have graphed on your graphing calculator. And so we're going to do that. I'm just going to show you how to test that. And then I'm going to talk briefly about slant asymptotes, also called oblique asymptotes. Okay, so you might also see them as oblique asymptotes. That's a U. Not a very good U. Anyways, there we go. Okay, so let's begin. Make some space for myself here. Okay, degrees of the numerator and the denominator. Let's go back to 9.3 in your textbook. Okay, let's take a look at this function right here. And it is x squared plus 2x all over x squared minus 4. Okay. Now, if we look at this right here, there's a few things that we've already learned how to do. We've learned how to, well, we know that we have to factor and then see if there's any common factors, right? So we could do that. Let's do x, oops, sorry. Let's do, take an x out, and that's x plus 2. And on the bottom here, we can factor this as x plus 2 times x minus 2, right? Because that's a difference of squares. So the couple things that we already know are that right here, this x plus 2 factor can be divided out. That means that x equals negative 2 is a gap discontinuity, right? We also know that this factor represents a restricted value, which is a vertical asymptote at x equals positive 2. Okay? We also know, and this is really important too, that the graph itself, the overall look of the graph, how the graph is going to look, it's going to look like this. Okay? And now, this may not be overly apparent, but if you were to graph this and this graph right here, if you were to graph these two, they would look identical. They would look absolutely identical. The only difference is this little gap here. And remember, unless you zoom in, you can't see the gap. So they're going to look identical. So if you want a simpler way to graph, you can just make sure you factor and divide anything out that's common. This is a little bit simpler way to graph. But I want to talk to you about horizontal asymptotes. That's the big deal. So let's just graph this real quick. Okay, I don't have that one up, but let's... Okay, so let's do this right here, x squared plus 2x, use your brackets. X squared plus 2x divided by... And make sure you use the minus instead of the negative there. Okay, and I don't know what my window's at, so I'm just going to do zoom 6 and let her rip here. Okay, so here's our graph. Okay, looks like this, and I mean, just for kicks and giggles here, we could just graph this one as well. You guys never heard that before, or is that just funny when I say it? Both? Okay. Okay. Okay, look at this. I graphed this one as well. Look at, where is it? Oh, there it is. Can't see it. Why? Because it's right on top of the other one. All right, they're really the same. And how do you know for sure? Well, let's trace. Okay, there's the first one, and here's the second one. Look at that. Exactly the same point, exactly the same graph. See that? So they're mapped exactly onto each other. Now, the horizontal asymptote. Okay, I know I said I'm going to talk about the degrees of the numerator and denominator, but I'm going to kind of skip ahead. This is what you already should know. Look at, it would be somewhere in between this. You see how when this approaches negative infinity, the x value gets smaller and smaller and smaller. It seems to be approaching some kind of hard ceiling here. And it would be the same over here. And so somewhere in between this part and this part, there should be a horizontal line that appears to be a horizontal asymptote. Okay? And it is true. And in this case, it's tough to tell with this, but I'll zoom in a little bit. Actually, I'll just change my window. So I'm just going to adjust my window settings here a little bit, and I'm going to graph it so I can see more of the graph as we go to it. Now look at this. With the resolution of the graph there, it appears that it's already hitting some kind of horizontal line here, right? But in reality, there is some kind of asymptote that it is becoming extremely close to. So I'm kind of skipping down, as I mentioned, to number 2, the second point here, how to determine from a graph. This is part of this section here, but it leads us to this shortcut, okay? So we go back to the graph. This is how you can find what the horizontal asymptote might be from the graphing calculator. You do second function, calculate, and you just do enter for value, okay? Now we know that we're going to 100 here, and the horizontal asymptote would be what the function is approaching as x approaches infinity. So let's check 15, okay? 15, that's going to be right there. What's the y value? 1.15. Let's do the same process and check 50. 1.04. Okay, so it's gone down a little bit. Now let's check, like 99. 1.02. So from 50 to 99, we've gone down just a couple hundredths, looks like. So if you were to guess at this point what the horizontal asymptote would be, what would you guess? 1. Okay, your guess would be y equals 1. Very good. And so this is a way you can try to confirm that with the calculator. Just check values, and you could even go ahead, window, let's go down to x max, let's make that 500. Okay, we'll graph that and look at that. You can check now somewhere close to 500, which we'll do real quick. Okay, value, let's do 499 and 1.004. So yes, y equals 1 is our horizontal asymptote. Okay? Now, let's get back to here, and if we look at y equals 1, okay, as the horizontal asymptote, I'm going to tell you how the shortcut works. And how the shortcut works is you really just look at the degrees of the numerator and the denominator. For those of you that have forgotten what degree means, okay, the degree is really the largest exponent on any of the variable, okay, on the variable in any of the terms. And so the degree of this numerator polynomial function is 2, because of that 2 right there. The degree of this one, the largest exponent on any x, is 2. So here the degree is the same, okay? When the degree is the same, you simply look at the ratio between the leading coefficients, and that is the equation of your horizontal asymptote. So I'll say that one more time. You look at the ratio of the leading coefficients from the numerator to the denominator, and that is your horizontal asymptote equation. Okay, so what we're looking at is we're looking at the degrees and of the numerator and denominator when they are equal. So the degrees here we said it's 2 and 2. When they're equal, the ratio of the leading coefficients, okay, that is the equation of the horizontal asymptote. Y equals, of course. So y equals, in this case, 1 divided by 1. So that gives you the equation of the horizontal asymptote. Okay? So other examples would be, get rid of this for now. Other examples would be, so as an example here, this rational function, if we look at this, the ratio, the degrees are the same. Okay, the largest exponent on any of the variable terms is 2 and 2 here. The ratio of those leading coefficients is 3 over 2. So let's just test this. If we look at the calculator, you type this in, and we graph, we examine this, it appears that the horizontal asymptote would be right in here somewhere, right? And if we test our theory and also graph, y equals 3 divided by 2, which is 1/2, and we graph this simultaneously, look how it appears to be, it's pretty close here. Now this comes pretty tight right there, but again, it's tough to tell whether that's the resolution or what, right? But anyways, it looks fairly reasonable, okay? It doesn't have to be right in between this one and this one always, but it sort of provides a, sort of a hard ceiling or a hard floor for where this would go as x approaches infinity. Okay, so that looks fairly reasonable. And if we extended the x max there, if we made that like 500 and graphed that, and then did a quick check at calculated the value at 499, then we get, look at this, 1.502, right? So 3 over 2, 1.5. So it looks pretty reasonable. Okay. Any questions on that? Okay, so the next piece to the puzzle here is what happens if the degrees aren't the same. Okay, so number 2, I know I didn't label number 1, okay, but this is really number 1 right here. Number 2, when the degree of the denominator, so that's the one underneath, is greater than the degree of the numerator, then the horizontal asymptote is always y equals 0. That one's an easy one. And this one you know of, right? Degree is 1 here. What's the degree on the top? 0, right? Because this would be like 1 plus x to the 0. Or no, it's not actually, but 1 is x to the 0, not plus. Sorry, I didn't mean that. 1 is really x to the 0, right? So the degree, now, and you know this one. That one looks just like this, where the horizontal asymptote is clearly y equals 0. But let's just test a couple more. Okay, so if we graph both of these right here, okay, 3x over x squared plus 1, if we graph that, look at this. This is 3x over x squared plus 1. Now, you may be wondering, where is our asymptote? There is no asymptote because the denominator here, there is no restricted value. There's no value for x that is disallowed or restricted. Why? Because if x is any number, it's going to be 0 or positive when it's squared. If x is 0, it's 0 squared is 0, not negative. If x is negative 5, when you square it, you get 25, right? So this will always be positive, never be 0. It'll never be 0. So there's no vertical asymptote. Well, even though it looks like it, well, if you say, hey, there's an x in the denominator, therefore there must be a restriction, then yes, you have to be careful. But because there's an x in the denominator, doesn't mean there's always a restriction. And no, it doesn't look like there's a vertical asymptote here. There's no vertical asymptote. I'm talking about the up and down vertical. The horizontal asymptote, yes, if you look at this, you say, hey, it looks like there's a horizontal asymptote as x gets increasingly large to infinity or to negative infinity. It looks like there is some kind of horizontal line that it approaches. And in this case, it would be y equals 0. So as we mentioned here in rule number 2, y equals 0 when the degree in the denominator is greater. Okay, this half of the room, you guys did this one. Did you come up with a y equals 0 for a horizontal asymptote? Did it look like that? Okay. All right. So when the degree of the denominator is greater, the horizontal asymptote is always y equals 0.